Hey there, this video will help you with the 1.02 assignment, Graphs of Functions. So let's go into a little bit about the kind of questions you're going to see and how to deal with those when it comes to the different types of graphs of each function. So the first kind of question you're going to come across is to determine what's called the local minimum and local maximum. So the keywords here are going to be minimum and maximum. So when you think of minimum, hopefully you think of bottom. So if I were to look at a minimum here on this graph, the very bottom would be this guy right here. So it only has one, because it's only got one minimum where it kind of curves. And then here in the second graph, I would say that's a minimum, because it comes down, stops, and goes up. And then here over here, I've got a second minimum. It's okay that it has two. It just means when we say local, what are the different minimums and maximums that apply to that specific graph? So I would definitely say in this first one that I have that one minimum there, and I have these two minimums here. Now let's change pen color so we can make it look really cool. We're going to look at the maximum, your highest point to the graph. But here I've definitely got a max right there. That's the highest point. And over on the second one, I've got another max right here. So don't always look for the highest point. Look at the crest. Look for where the graph turns. So where it turns like a hill, like this over here, that's going to be your maximum. Where it's the little valley, like over here, it's going to be your minimums. So when you're looking for your local minimum and maximum from a graph, you're looking for simply just your highest and your lowest points. And you're just going to identify those. So this ordered pair, this minimum here is -1, 0. And I'm just using the information from the graph right here. This guy over here is +1, 0. And then the maximum here, my x is 0, my y is 1. Over here on the first graph, this one right here goes over 1 on the x, and then down, looks like about -4. Then my maximum over here on the first graph is -1 on the x, and it goes up +4 on the y. So I'm able to simply identify them. So just look at them on the graph, identify their points, and boom, you're done. Then you're going to be asked to know, is my graph increasing, decreasing, or constant, and where does it happen? This one is a little tricky because it's usually not the way that you think. Remember that we read a graph from left to right, the same way that we read a book from left to right. So I want you to kind of burn that in your brain. When you're looking at increasing and decreasing, when you're trying to read the graph to see where that's happening, you have to read from left to right. So again, when I'm looking from left to right on this first one, this is an absolute value graph, I can tell because it's a V. You may have noticed that from your Algebra 1 and 2 experiences. When I'm looking for where it is increasing, okay, where it is increasing, you always refer to the X values. Always refer in terms of X. So here, I notice that it's decreasing right there. From left to right, my graph is coming down. So that's my decrease. Okay. Then over here, it starts going up. And from left to right, that's my increase. Okay. Here at the bottom, the very point of the V, the vertex of the V, the vertice, whatever you want to call it, is going to be a constant. Okay. Because it's not decreasing there and it's not increasing there, it's just remaining constant. So let's take a look at the second graph. Before we actually give it the numerical values, let's look at the second graph, make sure we're on the same page. Again, I'm going to read the graph from left to right. Looking here, I'm going to be increasing to about here. So that's increase. Increase in my graph there. And then here, looks like I'm also increasing. That's good news. The only problem here is that I am having a constant right there. So nothing's really happening at that point. So now we need to go ahead and give it numbers. let's go back to this first one. So when we talk about decreasing, again, we're always going to refer to it in x values. So it pretty much started at forever. Remember, forever to the negative is going to be negative infinity. So it decreases, it begins at negative infinity. Comma, where does it stop decreasing? Well, right here. The answer to that is not 1, 2, 3, 4. It's a very common mistake. No, we refer to x values. So it stops right here where x equals 1. So it decreases from negative infinity over to 1. Well, where does it increase? Well, it begins increasing at 1, but not on 1. So we'll do parentheses 1 up to infinity. Where is it constant? At the 1. Now the second graph was a little bit trickier. You probably won't have one quite like this, but you'll get the general idea. So the whole thing is increasing until that middle section. So where does it begin increasing? Again, an x value pretty much from forever. So that forever to the left, remember, is going to be negative infinity. It stops increasing. I may have colored this a bit too much to remember where we are, but at about 0. So let's do 0 didn't take, so infinity to 0. But then it also increases again. So if you have to list more than one increase, we're going to use the U for union. And it picks back up at, actually flattens out, I would say, at about 1/2, negative 1/2. Then it picks back up at about positive 1/2 on the x-axis and goes on forever to the right. So that would be forever, that'd be positive infinity. And so that graph is strictly increasing. So we don't have a decreasing section per se, so we'll say constant. Where's the constant section of this? Where did it not increase or decrease? Well, if we're going to say the negative 1/2, it began there, and it went to 1/2. Now the difference here is that it includes the 1/2s, so we're going to use brackets, because the actual points, negative 1/2 and 1/2, are constant. And so those are increasing, decreasing, and constant intervals. Most of what you're going to run into is going to look more like this graph right here, but I wanted to show you this one because you may get some stuff like this. You may have done some of it in Algebra 2. Okay, even, odd, and neither functions, you're going to be asked to algebraically show how this happens. So what we're going to do to test it is we are actually going to insert negative x into the x value to see what happens. So this first one, it's really 2 times negative x squared plus 5. I'm going to put it into the second one. It's 2 times negative x to the third plus 2 times negative x plus 5. Again, I'm going to do it to the last one here. 2 times negative x to the fourth plus 2 times negative x squared. So my first step was to go ahead and substitute them. Now I'm going to do all my exponents here and kind of rewrite these things. So negative x squared is just x squared. Squared, my plus 5 didn't change. Okay, my second one, negative x cubed, is going to give me negative x. So that's actually, we can just write that as negative 2x to the third. 2 times negative x will just give me negative 2x. And that plus 5 didn't change. Okay, now this last one, negative x to the fourth power, well actually, negative x to the fourth will be a positive, so it's going to be 2x to the fourth. And negative x squared is also a positive, so it's 2x squared. So what you're looking for now is what happened to these. You want to compare your start to your finish. These two are the same. So when they're the same, that means it is even function. Okay, this one, the middle one, the first number is the exact opposite, the second number is the exact opposite, but the third number is the same. So that actually will be neither. This is a tricky one because for it to be odd, If this plus 5 weren't here, let's do one without the plus 5 so you can see what I mean. 2x to the third plus 2x. If I did the same thing, I'd end up with negative 2x to the third minus 2x. Well, if you compare these two together, it's the exact opposite. And so when you have the exact opposite, it would be odd. On this last one, when you compare them together, they're the same, which means that they are even. And that's how you check your even, your odd, and your neither functions. You'll also need to create an even, odd, or neither function. So the main thing is if you go back and notice what we did on the last slide, what did you notice about the exponents? Well, for it to be the same, if you keep them even, then it's going to be an even. If you keep them all odd, it's going to be odd. If you mix them together, it's going to be neither. So for example, if I want to do an even function, I might say, and of course you're going to use your f of x, so that's function notation. I might say 2x to the fourth plus 2x squared. I know that because both of these are even, that when I plug that negative x in there, they're going to stay the same. If I want to do an odd, I'll do the exact opposite of that. I'll say f of x is equal, I can take the same idea, but do 2x to the third plus 2x. Because when I plug that negative x in there, it's going to be the exact opposite. And then for neither, I can just mix them. I can say f of x is equal to 2x to the third plus 2x squared. I've got an odd and an even, so this one will be the exact opposite, and this one will be the same, so that would be neither. So when you do this type of essay question on your assignment, you will need to explain algebraically and show that you put that negative x in there to prove that it actually is even, odd, or neither. And that should help you get going with this assignment.